In section 3b here, we're going to look at adding and subtracting algebraic fractions, but now we're going to need to find common denominators. So unlike the first part, okay, we won't have common denominators. And we will look at number 24 here. Okay, so think back to if I gave you this fraction. If I gave you 1 over 3 plus 1 over 4, numeric fractions. Well, the rule is, if I was going to do that, my common denominator is 12. Okay, so I would multiply by 4, so this would be 4 over 12. This one I'd have to multiply by 3, and then the rule was you add the tops, and it would be 7/12. You're going to do a similar thing with algebraic fractions. You need to find a common denominator. Now, in this section, we're going to look at them being monomials. So on 24, we've got 6x squared y as a denominator, and I've got 4. So I want to find the least common multiple, or what a common denominator would be. So if you think about what it would be for 6 and 4, it would be 12, and then I need to pick my variables. And in the variables, you use the biggest exponent on any variables that you have for your least common multiple. So here, my common denominator would be 12x squared y. And what I'm going to do is I'm just going to write it into one fraction over my common denominator. That's usually what I choose to do. And then I say, what would I multiply the 6x squared y by to get my common denominator of 12x squared y? Well, I have to multiply by 2. So I take the 5 on top times 2. So 5 times 2 is 10. Over here, what do I multiply 4 by to get 12x squared y? Well, 3x squared y. So I need to take the top times 3x squared y. So 5 times 3x squared y is 15x squared y. So I end up having a binomial on the top of 10 plus 15x squared y over this. Now remember, you can't cancel your x squared y's like from the second term on top with that on the bottom. But if I could factor something out, and notice the top is factorable, I have a 10 and a 15, I could take out a 5, and I'd be left with 2 plus 3x squared y, opposite of the distributive property. On the bottom, I'd have 12x squared y. Now, you just need to check, does anything cancel, because I have a monomial on the bottom. Well, 5 doesn't go into 12, so nothing cancels. So this would be the factored answer, which I like to leave it in factored form. This is the expanded form answer. But check to see if anything cancels when you factor. So let's go down to number 28 here. I kind of ran into what we were doing there, but if we look at 28, I've got 5 and 2x squared for my monomial factors, so that's going to be 10x squared. So this one over here I need to multiply by 2x squared. So I'm going to take this times 2x squared. So I'm going to get 5y times 2x squared is 10x squared y. The second one I need to multiply by 5 to get my 10x squared. Now you got to be really careful here. I've got a binomial up there, so I'm going to put it in parentheses, and I would suggest multiplying by 5 out in front, and you've got this minus sign right here. So I need to take this minus 5 and distribute it to x minus y. And I keep going up here, so that's going to be minus 5x, and then negative 5 distributed to negative y is plus 5y. Now, if you look on the top, I've got 3 terms. I can take out a 5 from the top. So what I'm going to do is, I'm going to take out a 5 from each of these terms up top here. If I take a 5 out, I'm left with 2x squared y minus x plus y all over 10x squared. And notice I got a monomial on the bottom of just 10x squared. Now that's times, so I can reduce the 5 and the 10 here. 5 goes in here once and in here twice. And so really I have 2x squared y minus x plus y all over 2x squared. And that would be your factored answer. And you could put the 1 out in front and put that trinomial on top inside parentheses, but you don't really need it.